Welcome back to our channel. In the previous session, we have discussed about the hydrological cycle and all the parameters related to hydrological cycle, both inputs and losses. So if you want to watch that video, go and check our channel. Okay. Now let's go to the today's topic. It's precipitation. So precipitation is the main input parameter in the hydrological cycle, and in this we will discuss thoroughly about precipitation. Let's go to the formation of precipitation. Okay, whenever you observe the image, whenever evaporation takes place in the rivers, streams or lakes or oceans, so here water is turned into the water vapor and forms clouds. Okay, whenever these clouds experience condensation means it is the process of converting water vapor to liquid or solid state again. Okay, so whenever condensation happens in the clouds, okay, under the gravity action, fall will occur. Fall means it is in the liquid form or solid form. Liquid form we call it as rainfall. Solid form we call it as snowfall. Okay, so this is the main concept behind formation of precipitation. Okay, so precipitation is the primary input for the hydrological cycle. Okay, so it can recharge surface water bodies as well as groundwater aquifers and maintain the water resources available in the earth's surface. Okay, it is also the main important parameter to be considered while design the hydraulic structures such as dams, spillways, and urban drainage, etc. So, any type of hydraulic structures means dams, reservoirs, spillways can be constructed by considering the precipitation in that region. Precipitation received in that region. Okay, and whenever the water vapor in the atmosphere matches to the 100% relative humidity, this process will be observed. Now let's see the forms of precipitation or types of precipitation. Previously we have discussed that rainfall is in liquid form, precipitation is in a liquid form or solid form. So here rain is observed as a liquid water droplets falling on the surface of the earth. Whenever comes to the snow, solid ice crystals are observed. Okay, here sleet means transparent ice pellets. Ice pellets means spherical shaped ice particles are observed. So uh, these spherical shape things are called as pellets. So transparent pellets ice pellets are observed in the case of sleet. Okay, and last one is the hail. Hails are observed during heavy thunderstorms. Okay, here large lumps. Chunks means here lumps. Okay, in cements we call it we can hear the word lumps. So that is here observed. Chunks means lumps. Large chunks are falling on the surface of the earth during heavy thunderstorms. Now let's see the formation of rain. Okay, whenever the water vapor condenses into aerosols or dust, okay, These are simply called as cloud droplets. Okay, so those aerosols or dust are formed as cloud droplets, and these droplets, tiny particles, nothing but cloud droplets. Those are very tiny particles. So whenever these tiny particles collide with each other and then merge, okay, merge and form as a larger, heavier raindrops. Okay, and this will fall under the action of gravity. Okay, so general diameter of raindrop is 0.5 mm to 6 mm, and intensity ranges from lighter drizzle to heavier downpours. So whenever technically said, how much amount of rainfall can be received per hour, it is nothing but intensity. So intensity can be less than 2.5 mm per hour for a little light drizzle, and greater than 7.5 mm per hour for heavy downpours. Okay, uh, and these are these are need to be calculated carefully for the engineering purpose to prepare the hydrographs, all the things. Now let's see the types of precipitation based on the lifting mechanism. Okay, so here we can see it as conventional rainfall. Conventional rainfall or conventional precipitation. It is observed when the localized heating of Earth's surface. Okay, it's caused by localized heating of Earth's surface. Okay? Here, simply uh, air first warms and then expands. Okay, rises rapidly, then cooling takes place to form convective clouds. Okay, so these will form intense storms. And then orographic. Orographic means one of the mountain ranges obstruct the moist air masses, clouds will form, and rainfall will be observed. So rainfall will be observed on the windward side. So wherever the wind direction is there, on that direction heavy rainfall will be observed in the orographic precipitation. And last one is cyclonic. Okay, cyclonic means collision of large air masses. Okay, whenever the different temperatures and densities are observed in the air masses, uh, those air masses will collide. Okay, and then heavy rainfall will be observed. Okay, simply speaking, uh, whenever if you have two large air masses, one is with one type of temperature and density and another with another type of temperature and density, whenever those two air masses collide with each other, then cyclones will be formed. Okay, and here widespread and prolonged precipitation events are occurred in the cyclone precipitation. Now let's see the how precipitation can be measured in the field. Okay, precipitation can be measured as a vertical depth on a flat surface. Okay, amount of water accumulated on the flat surface. Okay, it is typically expressed in mm or inches. So for recording precipitation, we have two types of rain gauges. One is non-recording rain gauges and recording type of rain gauges. So non-recording rain gauges are manual reading. So we have to check every day and check the depth of water accumulated every day. So simply it is called as a standard Simon's gauge. And recording gauges are automatically records the intensity. uh, these are mainly two types, tipping bucket or weighing bucket. So this data can be very useful to form hydrographs. Hydrographs means graphs drawn between rainfall intensity and time. So these are very important for engineering analysis. So these are all the things can be thoroughly discussed in the next video. Uh, so now let's just know the basic concept regarding measurement of precipitation, how it can be measured, what type of rain gauges will be there, and all the things. Now let's go to factors affecting precipitation. Precipitation mainly depends on the four factors. One is temperature, and other one wind patterns, topography, distance from sea. So warmer air keeps more water vapor and it will increase the potential cause of heavy rainfall. Okay, and then wind patterns in India we simply call it as uh, northeast, sorry, southwest and northeast monsoons. So that all depends on the wind directions. Simply call it as నైరుతి ఋతుపవనాలు or ఈశాన్య ఋతుపవనాలు, like that. It's based on the direction of the wind. Whenever the wind is flowing from north to east, one type of rainfall pattern will be observed, and whenever the wind can be observed from south to west, another type of rainfall patterns will be observed in India. Okay, then topography. So whenever the heavy mountains or forest areas will be there, then there is a potential possibility of heavy rainfalls. So in that case, topography plays key role there. And last one is the distance from the sea. So coastal regions generally receives high precipitation. Okay, whenever compared to the other inland areas or the areas far from the coastal regions. Let's talk about the importance of precipitation in water resource management. So precipitation is the fundamental input for hydrological cycle. That's it. But accurate measurement of precipitation or analysis and forecasting, all the things are very much needed to get sustainable engineering practices, flood controlling, and global water security. So measurement of precipitation is the key for all the things here. Okay, so that's it for today's session. We'll meet in the next session with the measurement of rainfall.